What's up everyone, I'm Chirag and welcome to this video tutorial. In this video tutorial, we will go through how to assign elastic IP to the Lambda function. So here at the high level, we want to make sure that each outgoing request from the Lambda function should have same IP address or same origin. Now you might ask that why do we need such kind of setup? So let's try to understand that. So let's consider a scenario where there is an API endpoint that only allows request from a specific set of whitelisted IP addresses, and here we want to hit that API endpoint from our Lambda function. So what is the problem? So the problem is that AWS Lambda functions get deployed in the AWS managed VPC and it does not have static IP addresses for each request. And it's because AWS Lambda runs on containers within AWS infrastructure in an AWS managed VPC, and at times different execution environment spins up to serve request and it may or may not have the same IP address. However, the same IP addresses might get reused multiple times for a number of requests depending on the execution environment reusability. But here we do not have control over the IP address allocation or execution environment. So the requests from the same IP addresses are not guaranteed each time. So this is our scenario and here we have a problem. So what is the solution? To assign the static IP to the Lambda function and make sure that all the requests made by Lambda function originate from the same IP address. So the solution here is to assign the static or elastic IP to the outgoing traffic from Lambda function, and for that first we need to configure the VPC along with the private and public subnet, followed by the creation of the NAT gateway and the internet gateway. And once the VPC is configured, we need to place the Lambda function within that VPC. So let's have a look at the high level steps that we might require in order to implement the solution. So we want to create the VPC with public and private subnets. Then we need to create the NAT gateway under public subnet with elastic IP. Now you might ask that what is NAT gateway? So NAT stands for network address translation, and the responsibility of the NAT gateway is to replace the source IP address or the private IP address with the NAT gateway IP address. And in our case, it will replace the private IP with the elastic IP. And whenever the NAT gateway will receive the response back, it will translate the address back to its original IP address, that is the private IP address. Okay, and then we are going to map NAT gateway within private subnet route table, and then we need to create the internet gateway. So basically internet gateway allows resources within your VPC to access the internet and vice versa. And then we need to map the internet gateway within public subnet route table. Finally, we will create a Lambda function and we will place it in VPC under private subnet. And now let's have a look at how our solution would look like. So here this is how our solution would look like. So here we have two private subnet and two public subnet, and our Lambda functions will sit in the private subnet and our NAT gateway will sit in the public subnet, and all the requests that is coming from the Lambda function will get forwarded to the NAT gateway in public subnet, and then NAT gateway will replace the private IP address with the elastic IP address, and then it will forward the request to the internet gateway, and finally it will reach the external API, right? So this is how the overall setup would look like. So now as a next step, let's go ahead to AWS Management Console and have the hands-on implementation. Now once we are within AWS Management Console, search for VPC and navigate to VPC Management Console. Now once you are within VPC Management Console, click on your VPCs from the left panel. So here we are going to create a new VPC, new subnets, NAT gateway and the internet gateway. Okay, so click on create VPC from the top right corner. So here under resources to create, we have two options. So if you want to only create the VPC, then you can select the first option. But if you also want to create other resources along with VPC, then select the second option. Okay, so I'm going to select the second option, and here we need to fill in few details. And on the right side, you should be able to see the live update or preview of whatever setup that you will do on the left panel. So the first option is that enter the name of the VPC. So you can check this auto generate if you want, and then enter the name. So I'm going to say Lambda elastic IP, and you should be able to see the live preview on the right side that the name of the VPC is updated to Lambda elastic IP VPC. Now here the next step is to configure the IPv4 CIDR block. So here we need to enter the starting IP address of the VPC and then provide the CIDR notation to define the size of your VPC. So here I will enter the starting IP address as 10.100.0.0, and then for the CIDR notation part I will say /16. It's because we want the subnet size to be as large as possible, and the acceptable CIDR notation ranges from 16 to 28. So here you cannot enter the value less than 16 and any value greater than 28. So that's basically IPv4 CIDR block. And then over here we will say no IPv6 CIDR block, and the tenancy we will select default. Now here we need to select how many availability zone we want. So I will say 2 availability zones. So just click on that. And if you want to modify or customize this availability zone, then you can click on this icon to expand. And here you can select the availability zone as per your requirement. Okay. And then here we need to select the number of public subnet that we want. So here we will say 2 public subnet and 2 private subnet. Now again, if you want to modify the CIDR blocks of your public and private subnets, then you can click over here. Now this public and private CIDR block are auto-generated based on what we have entered as a part of the IPv4 CIDR block. But if you want to modify this range, then you can go ahead and modify over here, right? But we are going to leave it as it is. And then finally, we also need the NAT gateway. So if you want one NAT gateway in one availability zone, then you can select the second option. Or if you want one NAT gateway per availability zone, then you can select the third option. So this will create two NAT gateway in separate availability zone for high availability. But as of now, we will move on with one availability zone, and then we do not need VPC endpoint, so I'm going to select none. If we look at the preview, then here you should be able to see that here we have the VPC, and then over here we have 4 subnet, 2 public and 2 private, 1 public and 1 private in each availability zone. And then here we have 3 route tables, 2 for private and 1 for public. In the network connection, here as you can see, here we have the internet gateway and the NAT gateway as well. Okay, so these many resources will get created. Now we will leave DNS option as it is and then click on create VPC. Now as you can see, the resource creation is in progress. So here you should be able to track the progress. Now while these resources are being created, let's go ahead and create the Lambda function. So search for Lambda and navigate to Lambda Management Console. Now once you are within Lambda Management Console, click on functions from the left panel and click on create function from the top right corner. And here we will provide the function name. So I would simply say static IP, and then I'm going to select runtime as Python 3.9, and I'm going to leave rest of the option as it is, and then click on create function. So here we have successfully created the Lambda function. Now let's click on configuration and click on permissions from the left panel and click on this role name. So since we are going to add or place this Lambda function within VPC, it would require additional permission to create ENI, that is Elastic Network Interface. So let's go ahead and add that permission. Navigate to IAM Management Console and over here, click on add permission from the right corner and say attach policy. And here we will look for VPC. So here we need to attach AWS Lambda VPC execution role. So check that and click on attach policies. So here we have successfully attached the permission that is required by Lambda function to create Elastic Network Interface. So now let's close this and let's go back to the VPC management console. And now here as you can see, the VPC has been configured successfully. Okay, so let's click on view VPC. And here you should be able to see the VPC that we have created, that is Lambda Elastic IP VPC. Okay, so let me copy this VPC ID. Let's click on subnets and let me filter it by VPC ID. So here you should be able to see 2 public and 2 private subnets, right, in different availability zone, followed by, let's click on route tables. Let me filter by VPC ID. Now here as you can see, we have 4 route table. One is main route table and one for public. So let's select this and have a look at the routes. So here you should be able to see that this 0.0.0/0 is automatically added and the target is the internet gateway. And for the private subnets, there should be an association with the NAT gateway, right? So here as you can see, the 0.0.0.0/0 is associated with the NAT gateway, and similarly for another private subnet, So this is how the route table, subnets and VPC looks like. And if we click on internet gateway, then we should be able to see the internet gateway over here. And then let's have a look at the NAT gateway. And here is our NAT gateway, and as you can see, the elastic IP address is allocated automatically. So this is our elastic IP address, that means the static IP address. Okay, now once we place the Lambda function in this VPC, whichever request that will originate from the Lambda function will have this IP address as the source or origin. So now here we have successfully configured the VPC. Now let's go back to the Lambda function. Okay, let's click on code. Now as a next step, we want to test this setup, and for that we will need to write a logic to invoke API endpoint. Okay, so let's modify this code quickly. So I'm going to import URL lib3, and then here I would say http equal to URL lib3 dot pool manager, and then here I'm going to define API URL which I want to hit. So I will leave it blank for now, and then I will say response equal to http dot request, and I want to perform get operation. So I will say get method on which API endpoint. So I will say API underscore URL. Okay, and finally I'm going to print response dot data. Okay, I'm going to save this and click on deploy. So this is our code. Now as a next step, let's place this Lambda function in the VPC. So let's click on configuration and click on VPC. Let's say edit, choose the VPC. So we are going to select the VPC that we have just created. So select that, select the subnet. So here I'm going to select two private subnets. So that is this one and this one. Okay, and select the security group, select the default one, and then say save. Now it will take some time to update or to place this Lambda function within private subnet. So while this Lambda function gets placed into the private subnet, let's have a look at the setup of the API endpoint or the REST API, where I can control who can access or invoke the API endpoint. So let's navigate to API gateway. And here I have this API, that is request API. So we are going to use this endpoint, this invocation URL within our Lambda function. And then if I click on resource policy, so from here I'm able to control that who can access or who can invoke this API endpoint. So right now I'm saying that if the request originates from 0.0.0.0, then only this API endpoint should serve or entertain that request. Okay, so right now no other IP address has been added over here. It's just 0.0.0.0. As of now, we are not going to modify this. Before we go ahead and add our elastic IP, let's try to invoke this API endpoint using our Lambda function first. Let's go back to the Lambda function. It's still getting updated. So in the meantime, if you want to learn how you can set up such kind of REST API where you can control the IP address, or how you can whitelist the IP addresses, then I have already posted a tutorial video on the same, and the link is in the video description. So let's go back to the Lambda function. So it's still being updated, so let's wait. So our Lambda function is updated successfully. Now let's click on code, and let's go back to API gateway and copy the invocation URL. Click on stages, version 1, copy, go back to Lambda function and paste it over here as a part of the API underscore URL. Save this and say deploy. Okay, so here we have successfully configured VPC, successfully configured Lambda function and placed it in the private subnets. Now we are good to test, right? So click on test from here and click on test again. Now it says HTTP connection pool max retries exceeded with URL caused by, so there is some issue. It says invalid URL, can't open. Okay, what is that? Okay, I guess we have a space over here. Let me Save this and deploy. Let's click on test again and say test. Now it says it is successful, right? And here we have a message. It says user anonymous is not authorized to perform execute API on the resource, right, with an explicit deny. So that means this Lambda function can access the services on the internet, but this API endpoint or this API gateway has denied to entertain that request, right? So here we have the error message that is with explicit deny. Okay, now if we want to successfully invoke this API endpoint or the REST API, what we need to do is we need to add that elastic IP within this resource policy. Okay, so let's do that. So let's navigate to NAT gateway and copy this elastic IP address, go back over here, and here I'm going to define a list, and here I will say comma and add another value, that is the elastic IP, and then I'm going to click on save, and then I will redeploy this API to version 1 and say deploy. Now once the API endpoint is deployed, it will take some time to reflect these changes. Now let's go back to the Lambda function and click on test again. So now as you can see, here we have the successful invocation message, right? That means we are successfully able to invoke that REST API endpoint by adding or allowing or whitelisting the IP. So here what we have did, we have just added this elastic IP address or the static IP address from where the request will originate within our external API, and here we basically whitelisted that elastic IP address. So whenever this Lambda function will send the request to that external API, it's going to solve that request and it's not going to send the deny message that we just saw earlier. So guys, this is how you can set this up. This is how you can assign or bind the elastic IP address with your Lambda function, and this is how you can make sure that each outgoing request from the Lambda function have the same IP address or the same origin. And I hope that you found this video helpful. So guys, that's all for this video. Until the time, if you want me to do tutorial on any use case or service, then please leave them below and I will try my best to come up with a tutorial as soon as possible. And if you have any queries or comments, then again please leave them below, and don't forget to like and subscribe to my channel, and see you next time.